Hello everyone. In this video we will see a demonstration of Linskite capabilities applied to a real-world problem, detecting scam in the Ethereum dataset. Linskite is a graph analytics tool designed to scale horizontally and so being able to address graphs of any size. Linskite offers two ways of interaction, a graphical web application and a Python API. In this video we will talk about the graphical web application. So the first step, of course, is to load the data that we want to work with. Let's see how it is done. Linskite offers tools to load data from a wide range of data sources like CSV files, JSON files, JDBC databases, Parquet or Hive. In this case, we will use the import CSV box. We will load the whole Ethereum dataset and also the addresses reported as a scam. Import in Linskite is very flexible because it allows to define a lot of important parameters like the columns in the file, the delimiter of those columns, the format of the dates, and a lot of other parameters. It also allows to see the output of this operation, so you can check that everything is alright. Like we can see here that we have the addresses that we wanted to import, and we have also the data from the Ethereum transactions. And Linskite also allows to perform SQL on these outputs, so you can further filter or process it. In this case, we have used an SQL box to select only the columns relevant for our analysis. Who is sending the Ethereum, who is receiving the Ethereum, the amount of transactions of the sender, the amount of the transaction, and the timestamp of this transaction. And of course, we can also see the result of this operation, and we can see that we only have the columns that we want to work with. One powerful feature of Linskite are snapshots. Snapshots allows to persist the result of any bugs to disk, so it can be used by other people or in other analysis without needing to recompute all the steps that lead to this output. Okay, let's dive into the analysis. In this workspace, we can see all of the steps of the analysis. We will start by building a graph from the data we just loaded. We can see that I'm using the import snapshot feature that I just mentioned to import both the scam addresses and the transactions data. To build a graph, Linskite offers a very convenient tool, the use table as a graph operation. This operation allows to define a column to act as a source and another one to act as a target, and automatically builds the graph. In this case, we have chose the from address, that is the sender, to act as a source, and the to address, that is the receiver, to act as a destination. As the result, we have a graph with 45 million vertices and 375 million edges. We can see that all the other columns of the table are added as edge attributes. From this, we want to filter the transactions that amount to 0 Ethereum, since we want to track the fraudulent flows of money. And for that, we will use the filter box operation of Linskite that allows to filter on any given attribute. And in this case, we will select only the transactions that have an amount greater than 0. Finally, we want to mark the nodes reported as a scam. For that, we will use the scam data and the use table as a vertex attribute operation. This operation allows us to join the scam data with the transactions data based on the address ID. Once we have done the join, we can finally derive the scam attribute that we wanted by checking the result of the join. In this case, we will assign a 0 to the addresses that are not in the scam dataset and a 1 to the addresses that are in the scam dataset. We can check the result of this join by using this attribute and the Linskite Instagram feature. With this feature, we can visualize the distribution of any given attribute. We can see that of all the 45 million addresses, 2,481 are marked as a scam. Now we are ready to start the feature engineering. Linskite offers a lot of tools related to this task. For example, as we have already seen, we can derive new attributes based on existing ones. For example, we can compute the logarithm of the amount of the transaction. Or we also can filter nodes and edges by any given attribute, as we have seen. But we can also do some more advanced computations, like building new attributes by aggregating the value of existing attributes for the neighbors. For example, we can compute the average and the sum of a scam in the neighborhood for each node. That is, the nodes that are connected to it. And we can select the target of this aggregation. For example, we can select to compute the aggregation only in the incoming edges, in the outgoing edges, or in all the neighbors. Linskite also offers tools to perform global aggregations. This is extremely useful to get some interesting insights in the graph. For example, we can compute the average scam in the graph, or the average degree for all the nodes in the graph. And of course, where Linskite excels is at graph-specific operations. We can do some simple tasks like aggregating parallel edges, that is, multiple edges between the same nodes. We can compute different aggregation metrics for each of the attributes of the edges, or computing the degree for each node based on different criteria. But the real power of Linskite is on the great collection of graph algorithms available. For example, we can compute the PageRank, the centrality, or we can also find the communities or the maximal clickers. And there is a large etc. on this. However, for this problem we have used a different Linskite feature, the ability to train general purpose machine learning models. To train a model in Linskite, you can use the train model box. This box allows to select the features used in the model and to also specify some model-specific parameters. For example, in the case of a decision tree classification model, we can select the maximum number of bins or maximum number of depth of the tree, amongst other features. And for the logistic regression model, we can select the maximum number of iterations. As the result of the training, we obtain a model with all the parameters. For example, in the case of the logistic regression model, we can see the coefficients for all the features used in the model. And in the case of the decision tree, we can see the whole logic on the classification. Once we have trained a model, we can use the classify with model box to use this model to compute predictions. In this case, we want to predict the probability of an address being fraudulent based on the scam features derived from its neighborhood. As the result of this classifying, we obtain a new prediction attribute for each node that will go from 1 to 0. Remember that we assigned a 0 to the nodes that were not in the scam dataset, and a 1 to the nodes that were in the scam dataset. Finally, we can use these scores together with the visualization capabilities of Linskite to support investigation cases. Visualization is one of the principal features of Linskite, and it allows for a lot of customization, making it very powerful. For example, one common way of working is first using the visualization tool to look at the whole graph to gain some understanding of the data and check the structure of the graph, like we are doing right now. For example, you can check which are the nodes that are at the center of the graph, or where are the scan nodes, how are the scan nodes connected, or which are the nodes that are of the side of the graph, for example. And once this you are done with this preliminary analysis, you can use this visualization tool and all the generated attributes, like the logistic model regression predictions, for example, to look for specific cases or perform a forensic analysis. For example, in this case, you can see that we have selected a few nodes and we have set the prediction attribute as the color of the nodes. So red nodes are scam and blue nodes are not a scam, or at least not predicted as a scam. And we have also set the amount of the transaction as the label of the edge, and this can be very useful. For example, in the early detection of fraudulent cash outs, we can use the scam prediction attribute to raise some automatic alarm blocking the cash out until some investigation is done on the origin of the money, and the investigator can use this tool, this visualization, to check where the money is coming from, if there are some scan nodes connected to this node, or how the money arrived to this node, or that kind of features that can be very useful to assess if the transaction is indeed fraudulent or not.